All right, so what did you guys come up with for the name of the first one here?
You wouldn't have the other.
Huh?
You wouldn't have to worry about the hexa.
Well, you don't put the A there. Well, let's see. No, because see, it would be hexene, so we take out, you don't have an A there. Okay? The root word with the suffix would be hexene. So we just split it right there. Okay? What's the next one called? Yeah, we went over that yesterday, didn't we?
Yep.
Okay.
I don't get that one.
Okay. Well, this is a cyclopropane here. Okay? 3 corners propane. It's in a circle. And so we got 2 methyl groups on positions 1 and 2. 1,2-dimethyl cyclopropane. If it's in a circle, it's got to be cyclopropane.
I get that part, but I don't get the back.
Methyl is, meth means 1 carbon, so it's a 1 carbon chain, YL. And we have to number it, so it's 1,2-dimethyl cyclopropane.
Why wouldn't you just put, or whatever you said?
Oh, because this is not 2 carbons long. You have to name each one of the side groups, side chains. Okay? And what are we going to call this?
Propane.
And this is the same as before. What's this one going to be called? Okay.
You would have to look at the one?
I thought it was Prop 1E.
Yeah, because we don't do it.
Yeah, but if you put it over here, it's still probe 1E. So if it doesn't help you any to put a number on that one.
Is that still right?
No, propene is better.
It's not technically wrong.
Well, yeah, that depends on what you mean by technically wrong. Okay. Look, if you only got 3 carbons, up to 3 carbons, 2 carbons or 3 carbons, there's no reason to number the double bonds or triple bonds because you can't go anywhere else. Just can't put it anywhere else. Okay.
Still the same thing, though. It's like the same.
It is the same thing, but it's redundant. Okay. All right, and this one's called. Okay. And what are we going to call this one? This is one we did not do spend any time on yesterday. 3-methyl pentane. There has to be a carbon right there for this side chain to be on it. Yeah.
Show the picture of the banner thing. That helped me understand.
Okay. I did put a little bend right there in that E just to help you out.
That makes more sense.
Okay. Well, there's no way to have a side chain coming off in the middle of a bond. You got to have a carbon there. So. Okay, but that does make it a little bit clearer. Okay. And we're going to call that R. 1,1-dimethyl cyclopropane, because it has to be a cycle here. Okay? And then somebody shouted out the name of this. Can you name this one now? Oh, what, you got a question about this one?
About the E. So is it a 3-carbon chain with side bonds?
Yeah, you got 3 carbons here. 1, 2, 3. That's a cyclo. Huh?
The E. Not the R.
Well, it's this part right here is cyclopropane. Oh, the E, I'm sorry. All right, pentane. 1, 2, 3, 4, 5 carbons. There has to be a carbon here for this to be tied to it.
I don't know.
How do you know where the chain is supposed to be?
Yeah.
Because you could have done the first part and then the bottom.
You choose the longest chain with the most. If there are functional groups on there, you will choose the longest chain with the most important functional group. In this case, there's only one side chain. The longest chain will be 1, 2, 3, 4, 5, not 1, 2, 3, 4. Okay, you choose the longest chain, and if there are functional groups, you choose the longest chain with the most important functional group. All right. So what are we going to call this? Hex 2,4-diene. There you go. Oh, sorry.
We didn't have to do the S.
No, I didn't put an S on there yesterday. I just thought about it after y'all left yesterday.
Can you explain the YL again?
YL is for side chains. That's a suffix that just means you have a side chain. Okay? It's not part of the parent chain. Okay?
Can you show how you would number the A?
Number this one right here?
Yeah.
Okay, well, the most important group here is this circle group, or it's called a cyclo group, okay? Because it's like going around and coming back to itself, okay? So that's a cyclopropane. And then if that's a cyclopropane, then you've got two methyl groups on adjacent carbons. I could put two methyl groups in the same carbon. That's exactly what I did somewhere else. Where was it? On the R down here. So I have to number them to show where the side groups are going to be located.
So how would you number it?
You just pick one of them and that number the next one close, the next number.
Can you just do one randomly?
Huh?
Can you just do one?
Yeah. I mean,
Can you do one?
can I? Sure I can. Do you want to do something different than this?
No, can you number the A?
1, 2. But it doesn't change the name of it if I say 1, 2.
How could you go on 1, 2?
What if one was at the top and then 2 and 3 were at the bottom?
Then you wouldn't have the lowest possible numbers to the functional groups, would you?
How could you not go 1, 2, 3 like that?
Because that wouldn't be the lowest numbers to the functional groups either.
Okay, can we do more examples? Or like time?
Well, we're going to keep doing more and more examples today. So, all right. So I got the banner up. Is anybody planning to come after school today? Try and help you, Gar? Okay.
After today or tomorrow?
Well, you can start today. People can start today.
You say we
For a
can
little
come
while.
before school?
Yeah. Okay. That's fine. We'll just keep up with how much time you put in and whether you're just playing around or you're actually working. So. You come by yourself?
I guess.
Okay. That's too bad. It's always more fun when other people are around. All right. There you go. Well, we'll have to figure out how to do the upside. It's kind of something I just kind of thought of on the spur of the moment last night. So. All right. So you begin to feel a little more comfortable with these now?
Yeah.
Now we've had a night to practice it and let it digest a bit? No? Yes?
Yes.
All right, so we've gotten through the triple bonds and we introduced the side chains with the YL endings. Okay? So I guess the next thing we need to talk about are phenyl groups. Okay? Then I don't know if we talked about what a benzene ring is?
No.
Okay. So let me introduce you to the concept of a benzene ring. Huh? Sure, sure. All right. So let's see. We've already figured out how to name this. Okay? What do we call that? Cyclohexane. If I put a double bond in here, then what are we going to call it? Cyclohexene. Okay? Now, I don't have to number that one because it's always going to be number 1. No matter how you number it, the lowest number is the number 1, right? Okay. But if I put 2 of them in here, now I have to number the double bonds. Okay? So this is going to be what? Cyclohex 1, 3. Okay, 1, 3. Okay? So you got if you start from here, you go across the bond to the next one. Okay? Whatever gets to it. Okay? Basically the same idea. All right? So that would be cyclohex 1, 3, actually diene. Okay? You have to say there's 2 double bonds, so diene. Okay? Cyclohex 1, 3 diene. And if I put a double bond here, there you go. Cyclohex 1, 3, 5 diene. Now, triene, I'm sorry. I'm sorry. And bear with me, my voice is about to go. Help me out here. Where did I put my pen? There it is. Now, need to kind of imagine a little bit. Use your mind to imagine a little bit. Think about the double bonds. We had to draw those in the last unit. So we had a sigma bond, and we had double bonds that had 2 parts parts that go above and below the single bond, the sigma bond, okay? So these double bonds are sticking up from this and going back behind. It's like we're forming, you know, a double bond there and there and there, okay? In fact, when you get double bonds adjacent to each other like that, something strange starts to happen, and it's called delocalization, okay? It's called delocalization.
Will you define that?
Yes, I am going to define that. And it's delocalization is what is part of what happens when we call it gracious, word escapes me, the one that was on my mind a second ago. Resonance. So those of you hearing music, you know what resonance is, right?
Yes, sir.
Okay. So resonance means the sound's bouncing around in a room, right? Basically. Okay. Well, these double bonds are bouncing around this structure. And we have a resonance structure. So what's happening is the double bonds, the electrons in this double bond, isn't fixed between these two carbons. It's going through this whole structure. Okay, it's a delocalized pi bond.
Does it matter which direction they go?
Not really, because really moving it there is not really what's going on. What's really going on is they're in all those places at the same time. I know it's kind of strange, but that's kind of what's happening. The electrons in a pi bond are not centered between two atoms.
Wait, what are we?
They move around.
I thought we were supposed to like, having resonance.
That's delocalization. In this context, they basically mean the same thing.
Isn't that true for all electrons?
To a degree, yes. But what's unique is that the electrons in the bonds aren't centered in here. They actually are moving around constantly. It's not even a percentage, you know, like 95% here and 5%. It's constantly through the whole thing. Yes.
Can you repeat that definition one more time with the electrons in the pi bonds?
The pi bonds are not stuck between two atoms. I said centered between two atoms, okay? The pi bond electrons are moving around between more than one set of atoms. And so it's a resonant structure, and we call it delocalization when the electrons do that. Okay? So because the electrons really aren't centered in one place, this drawing, even though we use it often, is not really indicative of what's really going on. So we also have another way of drawing this kind of structure that gives us a better picture of what the electrons are actually doing. Okay? And this is an important structure. This is an important structure, and it has a special name. Benzene. Why?
Because I use accent.
That's right, because